Okay, this is Business 342, page number 80, problem number 8. This is actually in your workbook too, exactly the same problem. A portfolio has 2 million invested in asset A and 3 million in asset B. Using the input data provided in the following table, calculate the mean, variance, and the standard deviation of the portfolio. Okay, so first thing you need to do is calculate the weighted average for each one. Weighted average is, in this case, we've got 2 million in A, 3 million in B, so 5 million total. So the weighted average for A is 2 million over 5 million is 0.4. And for B, it's 0.6, 3 million over 5 million. Then the expected return. The expected return is just the weighted average times the expected return for the portfolio is the weighted average for each stock times the expected return for each stock. So that gives you the expected return. Now they calculate this a different way because they gave you this other information than doing the variance the other way. So we'll do it the way that they've got it. The variance, and maybe because they've got the standard deviations for each separate one in a correlation, they're doing it this way. So the variance, which is the standard deviation squared, equals 0.16, which here's the formula below. The weighted average of A squared times the standard deviation squared. So the weighted average is 0.4, so that's 0.16, because 0.4 squared is 0.16. Then the standard deviation is 12, so it's 12 squared, plus the weighted average of B, which is 0.6, so that's 0.36 when it's squared, times 20, which is the standard deviation squared, plus 2 times the weighted average of A times the weighted average of B times the covariance of A and B, which equals this formula, which is the same thing, the weighted average of A squared times the standard deviation for A squared, plus the weighted average of B squared times the standard deviation for B squared. This is the same times 2 times the weighted average of A times the weighted average of B, and then this right here, P, that is the correlation. So when you see correlation here, P, so instead of figuring out the covariance, there's a formula for figuring out the covariance, but and that's correlation equals P, which is correlation, which is the well, I'll write it down in just a second. The covariance of XY over the standard deviation of XY. But you don't need to know that for right now. So anyway, this is correlation. P is correlation. So they gave you that. So instead of having to do the covariance for AB, you've got the correlation for AB because they tell you right there 0.4 and times the standard deviation. So this gives you covariance. Correlation 0.4 times the standard deviation of A, which is 12. See, they got 0.4 times 12 times 20, and the standard deviation of B. So this formula, this is in your book on your workbook on one of the pages, page 81 or 82 or 83, something like that. So that's how they calculated this variance. Because remember, once you get the variance, which is 213.12, you can figure out the standard deviation for the portfolio. They gave you the standard deviation for each stock. They gave you the correlation between the stocks. But you could figure out the standard deviation for the portfolio right there, 14.6. And covariance equals P, which equals, let me look this up real quick while we're online here. The covariance of XY, which we don't know what that is, of XY over the standard deviation of X and the standard deviation of Y. Let me make sure that's right real quick. Yeah, covariance of xy, and I'm not sure how to figure out the covariance, but as long as they give you the standard deviation, the correlation. Covariance, this is correlation, this is even covariance. This is correlation. The correlation equals P. That's why they've got P back on this formula instead of having to do the covariance stuff. So that P right there, P of A and B, is the correlation of A and B, which they give you. So correlation equals P, which is the covariance of xy over the standard deviation of xy. So this formula also equals this formula, except here they're using correlation, here they're using covariance. That's why they gave you correlation. So that's problem number 8 on page 80.